This course is 520. Anyone here trying to sit in for different class? 520, right? Okay, 560 is tomorrow. So the title of this course is very, very, very heavy duty and old-fashioned, real, more academic terminologies, which is knowledge discovery and data mining. These days, I mean not these days, but till recent years, so many researchers and instructors call the same field data mining. And then recent years, since a few years ago, everybody is speaking out so many different buzzwords, including big data, data analytics, data science, and all such things, right? But the area of knowledge discovery and data mining has been on market several decades. Okay, several decades. Technology have been developed for many, many years, and now it is time that we can say data mining or data science, data analytics. All such buzzwords are so popular and also practical because there has been long developed technologies. Okay, so in this class we are going to discuss concepts and algorithms, theories behind data science, behind the data analytics or big data, whichever you think would be appropriate. Okay. Let me first check who you are. Online students, because I'm recording this course also for online students to watch, not just looking at the slides, but they don't see me. If they see me, then they may be delighted, or they may be disappointed. But anyway, but my voice only. Anybody here finally see me face to face after long listening to my voice? Okay. Because I want to hear something from them. Okay, this is online course, I believe, right? First instance is not available already. Stephanie not here. Ivan? Yeah. David? Yeah. Shin Cheng? Oh, you're Shin Cheng? William? Caleb? Where were you?
Right here.
Okay. I mean,
I took another class.
I see you once in a while,
Yeah.
which makes me delighted. Keith, Matthew, good to see you.
Likewise.
Yeah. Yuhan, Manifold. I don't know why. Dries. Dries. Edmond. Kim. Johnny Villa. Ellen. Yeah. Isaac White. Izwan? How do you call yourself? Your name?
Yishuan.
Yishuan?
It's a Chinese name, but you can call me Jerry.
Jerry?
Yeah.
Okay. Yishuan. Okay. Who am I missing? Isaac, Johnny, Joris, Nguyen. Nguyen is usually late. Catherine Escalon, Shi Chang, David, Ivan. Okay. Okay, good. So let me close this. Let me bring up one more time. So syllabus has been posted. So you can see the syllabus of this class, right? There is the current version, which means in a couple of weeks, if there is anything that we need to change, modify, we will do. But if it doesn't happen, then we will stay with this syllabus. That is a current syllabus. I want to read the syllabus on your own. If you have any problem, you can. I want you to read, scan through right now. If you have any problem, questions, then you can ask. But I'm going to review with you a little bit something important to yourself. Your name is? Dris? Okay, Dris. Let's see. Oops. Okay. Lecture format, the class format. Here, right here, main hall 314. Wednesdays, it starts at 6:15. Lecture slide always posted on Blackboard. The first slide also available on your Blackboard. If anyone does not know where you can find it, then I will help you. Go to Blackboard website, then there is a course material. This on-site class, all the slides will be in one folder. Okay? Online class is different. There's a module by module, but it's all slides in one folder. So if you click this, then you can see. It doesn't. Doesn't move. Can you see the slides in your
The
Blackboard?
slides, oh, you mean that, literally the slides?
I don't know why. Mine is not clickable. Okay, slide here. So you can see the course material of this class. Okay. This class, I think you can see this slide also, right? Okay. For online students, I'm also recording my lecture. Voice and my monitor screen will be recorded. But this video clips may not be available for on-site students. It's too much work for me. Hands-on labs, also a class, but online students need to do only by looking at my video clips. If you have any problems, or if online students expect any difficulties, I want you to join those sessions only in person. Homework assignments also posted on Blackboard. Homework assignments should ask something about hands-on exercises and research paper reviews and research concept reviews also. So you will see that. Evaluation of this course. This slide may be one of the most significant or interesting slides to you. As you can see here, we have one exam, one and only one exam, which is 45%. So you have to prepare this exam very carefully. On site, here. I'm not sure. Maybe online, because we have online students. Homework assignments are 25%, project 25%, and your participation will be 5%. Okay. We have a project to be conducted as a group. In your case, online students may do individually, but I want a group project to be done by on-site students. So you need to form a group and conduct a little bigger project.
Oh, Dr. Yoon, when is the proposal due? Because it says June 29th, and I assume that's a mistake.
What is the June 20? I said
On
October 31st.
October 31st, okay. No, on the, it says, I see, it says the proposal is due June 29th.
Oh, oral presentation? Oh, I see what you mean. Oral presentation, July. And also top?
Yeah.
Where?
It says June 30th, June 29th.
Oh,
I'm sorry.
proposal. I'm sorry.
No, it's okay.
Why?
I just wanted to bring it to your attention before
Oh, yeah.
it's posted to the online students.
Exactly. This is not right. I need to change this. Should be, yeah, proposal October 31st.
Okay.
And then written report that can be found in the syllabus.
Okay.
Let me bring up the syllabus here. If you see the syllabus, the last page. There's a timetable. Okay. We will have a 15 weeks. The last week, 15th,
Yes, it's 31st.
project report and presentation. I believe that is December 22nd or the 4th. I think 22nd.
Let's check the academic calendar.
And the proposal is due on October 31st, midnight.
I think it's December 21st would be that Wednesday.
December 21st?
I believe so, because
Okay.
it ends Friday, December 23rd.
Okay, then I will change this to December.
I'm terrible with basic math, so.
December 21st.
December
Midnight.
21st is a Wednesday, yes. And that'd be the last one of the semester.
Okay, that is my correction. Okay. Again, why? Can I see laser pointer? Oh, this is good. Okay. Oh, it is not really good to you. It's good to me only.
No, it's kind of painful to look at.
Yeah. Let me see. Highlight. It's not really. The screen does not have this. Okay, forget about this. All right. So proposal due on October 31st, midnight. So as a group, you have to write one proposal, but submission should be done each individual. Why? That is for me. I'm grading all of your submission from my Blackboard. So when I open your grade, if you do not have anything, then I have to do it manually. I have to find out who the person submitted on behalf of you, and then come back to your grade book and then change whatever the grade. First of all, it takes so long, and then most significantly, I may miss. If I miss, then you don't get that grade, which is no good, right? So it is your responsible to submit each individual. Work should be done as a group together, but submission should be done in the individual. So the work in the Blackboard should be under your name. You see what I'm saying?
So are we breaking down the project by individual group member?
Oh yeah. A real work should be broken down. So you can do, for example, part 1, and your friend will do part 2 and part 3. But report should be all in one report. Okay, so that your report says chapter 1, chapter 2, chapter 3, or section 1, 2, 3, 4 as a one solid report. That one should be submitted, each individual. So supposedly if you have 3 students in one team, then each individual should submit the exact same report. But as I will...
Then they would submit the full report, but then also the individual...
Also, that is a good question.
No, we don't have to... we have to submit the individual piece too? No. Or
No,
just
not
report,
here is. So his question is how do I know who has done what, right? So that is the reason I said here in your report, if that is a group project, in your report, you should say, you should include one table. That table has student name and then work accomplished. So that, for example, here, David, you can say David. And David did section 2 and 3.1 and 3.4. What does that mean? So you might have more subsections available in section 3. So he does a section 1, section 3.1, 3.2, 3.3, 3.4. And then 3.5 will be done by someone else. Section 3.5 and section 4, for example. Okay? This is done by Edmund. Okay? You're going to be in one team? No, you don't need to. Clear? Lady, what is your name?
Salar Majid, I'm in your online course. We spoke earlier.
Oh, yeah. You're online students. Okay. Any question about your...
Yeah, it does that every time you switch into a slide. It'll go.
Projections.
Yeah.
delay?
There it goes.
Any question about this slide? It's a group project for on-site students. But online students can do group project, but technically many times impossible. So individual project is assumed.
Can on-site students work with online students?
Then there is a group project, of
Yeah,
course.
yeah, okay. I was just curious.
Yeah, why not? That is, yeah, I don't think there is a restriction at all. Okay. Topics of a project. Also, let me see. Oh yeah, I have it here. Available on the syllabus that syllabus here. Where is it? Yeah, some of the topics that I listed here, but you do not need to. Definitely, I think you probably need to the topic that you are going to work on for this semester should fall in one of the categories here. Otherwise, it would be really good data mining topics, or it is drifted away. So you may do something like digital signal processing for data mining, which is not good, right? Well, which is a good subject, but it's not good for data mining. So you can read this, but if we see together here, first of all, data collection mechanism or data cleansing, that is also a very, very important issue. Why? We all know that when you say data, then there is a big data, right? So all kinds of data available. for your data mining process. So you need to clean out some. Otherwise, it is really big. If you join two different big data together, then there's a lot of missing matches. So you have to clean out your data before you apply data mining algorithms. So a lot of issues available. What statistical analysis, as you can see here? Oh, you don't see this. It's really strange. Only I was just talking about my monitor is not the same as your screen. Sorry. We need a little fast processing. That was what I'm talking about.
Oh.
Okay.
Let's
First
put it-
bullet and second bullet, statistical analysis, and third bullet, rule mining. When you the utmost goal of data mining is to generate a rule, so that that rule can be used for further processing. For example, if you have big data about criminologies, crimes data, then what? If you find some rules, and if that rules is accurate, at least, for example, some certain percentage, like 90% accurate. Oh, we have officer there. So we have some criminal detection rules discovered from big data, so that if because the rules that you discovered is so accurate, that is a big assumption. Anyway, if it is accurate, and also it covers many cases, then you can apply that rule more frequently, right? Although it is accurate, it doesn't happen often, therefore it may happen only once a decade, then it is not really the rules that you want to apply, right? All the cases when you catch somebody, then you better forget that rule, because it may occur only once a decade. On the other hand, some rules discovered, it occurs every moment, even 10 times or 100 times per hour, so that you always get alert. But if it is not accurate, but if you apply that rule to whatever suspect, then that is also a big problem, right? But anyway, there are some issues. Therefore, accuracy issues, soundness issues, completeness issues, interestingness issues, confidence issues. All kinds of measurements needs to be made before you use. But anyway, rule mining, therefore, is another topic that you may consider. Another thing is data classification. Particularly big data, then is overwhelmingly enough data available. So by looking at each individual data points, oh my God, you cannot see what's going on. Day by day, you read all the data, you have no clue at all what's going on, all different scattered data. But if you have very good algorithm that can classify your data, so that can say that, hey, I can categorize the data in this way, itemize the data in that way, then that is very useful, right? So you can see here two terms, classification and clustering. Looked similar to you, right? Classification and clustering. Many cases, in your day-to-day life, you exchangeably use at one time classification, another time clustering, right? But in data mining, clearly there is a difference. Can anyone imagine the difference between classification and the clustering? Classification assumes initially a fixed classes. So it defines class first. Hey, this is a gentleman class. This is whatever class. Okay, class A class, B class, C class, D class, E class. 5 classes first defined. And when it comes to new data, applying some rules and determine, hey, put this in the class B. Next data, hey, this is in class C. Another data, this is in class A. If you do that process, then it is called classification. So classification is very similar to clustering, but it has its own unique characteristics, which is it has predefined classes first. On the other hand, clustering. Clustering is very similar to classification, but there is no classes defined. No predefined classes assumed. But by looking at data sets, you can divide them. Therefore, in extreme case, if you have one more data item in, then you might have totally different clusters, totally different classes obtained, because there is one more data item, which is not the case in classification, right? Classification, classes are defined. For the one additional data, then only thing that you need to do is to determine which class that item needs to be in, right? But clustering, by looking at one, so that you may see different classes, but outcome of clustering is not called classes, but we say clusters. But they are very similar, right? Outcome of classification is a number of classes. The number. Outcome of classification is classes, set of classes, fixed set of classes. Outcome of clustering is a dynamic set of clusters. Sometimes you have 5 clusters. Some other times you have 3 clusters. Some other times you have 10 clusters. So it is more data-driven. Okay? That may be a topic that you can think of. You can develop some a new algorithm, or you can implement some algorithms that you are interested in, or you can apply the algorithm to a specific application domain. That is also possible. Hey, I like this association rule mining, the so-called association rule mining, which is one of a typical example. So if you like, oh, I like that, so can I apply this? So among the group members, you can say, oh, where can we apply this? And find out, oh, I want to apply this at packet analysis, network packet analysis. You could do that. I want to apply this to forensic investigation. Okay? Okay, back to slide. Oh, this time so quick. Okay, next slide. Topics to cover in this class. Broadly, two issues: theoretic issues and practical issues. So we will look at theories. Basically, we will look at association rule mining, classification, and clustering. Those three major technologies will be discussed. And hands-on exercises. Someone here probably knew that I like programming much, right?
Yeah.
So I'm requesting always some programming to you. If you hate programming, please do not hate me. I'm not programming itself. But why I ask you to do programming? Why programming is important? If I teach you programming, then is it good for me, or is it good for you? Or bad for you? I believe it is good for you. The future. Information world. Wherever you are working on, whatever the problem that you want to solve, if you do not know the coding, I'm not talking about real big and professional coding. If you do, then much better. Even if you don't, still okay. I want you to do a little bit of programming so that your work is not 100% dependent on some software already developed or developed by some other companies, but not your own company. Instead, whatever the problem occurs, if that is a significant problem, then there's no such software available for you to use to solve that problem, because that is significantly new, right? Then if you are able to code and implement a little bit, or at least to tweak the known software, then your career will be stable and strongly recognized, right? At least. So, the language that I want you to know from this class, well, whoever joins cybersecurity program needs to know at least one language, if not two or three. Then that language is Python. If you really like Python, and if you know much about Python, so that, hey, I need one more language, then you can do some other language. Okay, for cybersecurity, C definitely better than Java, right? If you want a third language, then maybe Spanish,
PHP,
Java, right? PHP, whatever you can choose, right?
French.
Yeah, Korean. Okay, for this class, Python is a good language. This is more general purpose language, so that I hope all of you know this. More specifically, for data analytics, all is also very, 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 very powerful and easy to run, and outcome of our computation is great. If you do that in Python, then you probably need like 50 lines of code. But if you do that in all, then one line gives you, boom, very big analytics.
It's a lot like APL. APL, it's an older language from the 60s. But a lot of things
okay.
you can do in APL, you can do in like 1 or 2 lines, and if you do it in like C, it's like 10.
David, we're not in 20 years ago.
I had to learn it for undergrad.
That is longer than 20 years ago.
Yeah.
Okay, if you see this table, look at this. What is the title of this table? What programming or statistics language do you use for analytics, data mining in the past 12 months? In the past 12 months from this time? No, it's a longer. But now, it's more critical. So R is the best language for you to do data analytics or whatever, right? And then the next one is Python, SQL, Java, SAS. For data mining, C or C++ is not really the best language. In general, it is a very good language, but for data mining. So what we will do is we're going to pick 2 languages, top 2 languages for data mining, R and Python. So we'll look at Python-based data mining, a little bit of those, and then we'll look at all, and finally put them together, Python and all. Here's the problem. Python and all, each individual can run on Windows, Mac, Linux operating systems. Each individual can run very nicely, successfully in any platform. But if you want to find out some integration, what is the integration of Python and R? There's 2 ways of integration. Python controls R. R controls, R is not really control. R uses Python. 2 ways. What did you say?
It's kind of like embedded to the R.
Oh yeah, it is embedded. Yeah, some R code can be embedded in Python. So as Python is running, Python understands R language, and therefore at that time R engine is activated and takes some data from Python programs, and then because R has very strong features, which is statistical analysis, so it does some work and then send it back to Python, and Python will do something.
So it is like an interpreter.
No, it's not. It's more tightly together. it's not manually back and forth. I'm explaining that way, but
Okay.
it is one file. Okay, a sequence of a statements can do both of those. But only problem when you do this is it's not going to work on Windows. Sorry. If Windows is the only platform that you know, then that is the problem. Real problem? No, not real problem. We'll provide you so that you can access our lab server. We have Ubuntu running on the server. So you need to access that server and do Python programs together with R, and then you will get some result from there. Okay? That is really challenging to those who never have experienced it. Is it too bad? Or is it good? I believe it is good. You should know, right? Some integrations. In that way, you can handle big data. R itself cannot handle big data. R is a very, very useful and powerful statistical analysis tools, but problem with R is it has limits. It cannot do big data at all. At all. Python can handle a lot bigger data than R can do. Okay? So third bullet here is not going to be on your personal laptop. You need to come to means virtually. You can log in from where you are. I'll let you know how to do that. Those who have some concept, here is what we need to do. We'll access Mercy VPN, okay, virtual private network, and then from there you can open up a PuTTY. PuTTY is secure shell emulator, so that you can get in the server Ubuntu. From there you can run Linux command. Okay. Question?
Yeah. Can we do that locally also if we want to set up our own Linux VM or run Linux natively?
Oh yeah, that is a very, very good question. If you have a VMware or Oracle VirtualBox, you could do that.
Okay.
But the reason that I am not going to do is it is all totally up to your own responsibility.
Okay.
When I do that way in class, then usually 50% or 70% of students say, "Oh, I cannot do that." So from that time, class cannot move forward because not all students have the same work environment. So this time, I assume everybody has Windows or Mac. Mac is okay. Mac, this third bullet, Mac can do. Or Linux running on your virtual machine, sitting on top of Windows, okay. But we need to be on the very same page. Okay, that is our Linux server. Question about that? So first and second bullet here, this and that, you can do. You don't see my cursor. I moved my cursor often. Never, right? On your screen. What is the problem? Pen, laser, pointer tools. Let me pick ink. Yeah, red ink, so that I can do pen. Oh, now I
Is it
have.
not mirroring, possibly?
Okay. Oh, now you can see. Okay, this is all. And Python. All right. And then Python integrated with all. So Python and all. This third bullet is available on Linux only. Linux-like operating systems. So Mac OS 10, also good for this. I tested OS X. Anybody has an iPhone 7?
No, which Linux is the best?
Which Linux is the best?
Or Ubuntu?
Ubuntu is easiest and good for us. So we're going to work on Ubuntu. We have also Red Hat based platform available on the server, but for this class, Ubuntu or OS X. These two Windows can handle, Windows can support. All right, we'll have a project week, the last week before exam. That is the week. Hopefully, if I deliver all the materials for this class by that time, then we'll have one free week. You can come here and then as a group you need to complete. Or for individual, then you might have an extra time to complete your project. All right? At that time, you can raise questions, you can just help each other. Okay, any questions so far? So I want you to look at, read very carefully, multiple times, the syllabus of this course. So do not be confused. For email, on-site students are discouraged to write email. Why? I want you to come physically in this class so that all the questions that you might have needs to be resolved in this class. Okay? Do not expect, for example, do not plan to miss classes and ask a lot of questions through emails. Emails is widely open to online students, but not on-site students. Okay, but if you have a real urgent issue, then you could do that too. Homework assignment submission. do not, I will not grade your homework assignments if you submit as an attachment to my mercy.edu email account. That email is not for this class. That is for my, I have a lot of other correspondence, for example, NSA, right? So do not submit your homework assignments to that email account. Your homework assignments needs to be submitted in the Dropbox. Many times, if you miss the deadline, then you cannot see the Dropbox. Therefore, some student says, "Hey, professor, I do not see the Dropbox, so that I cannot submit. So can I submit as an attachment to your Blackboard email?" Which means you said, "I missed the deadline." If you missed the deadline, yes, still you can submit, but please do expect some point cut off. Okay? And if you submit your homework assignments not the way that I suggest you to do, for example, dropping in the Dropbox, so that I can see your submission from your grade books. That way I can give you comments. But if you give me email as an attachment, then my comments to your homework assignments is really hectic. I need to reply to your email. When I do some comments on your attachment, then I need to attach that once. I need to save that and then attachment to back to you. So all such things is not the way that we want to do. Okay. So if you miss the deadline, then you do not see the Dropbox. Therefore, after that point, you might have a lot of disadvantages, okay? Because you missed the deadline. Question?
So where we can see the link of Dropbox, where we
Dropbox is, Dropbox is simply, if you come here, course material. Right now we have only one slides, but another item here. Then I would say homework 1. Another here, okay? Homework 1. Then if you click that homework 1, then you can see there's a submission. So that you can bring your file from your local storage to post, so that that submission will be on your gradebook. So the way that I grade yours is open up your gradebook, and then I can find your submission, and then I can give you some feedbacks and more appropriate ways, right? There's a fast and appropriate. If you don't do, because you missed the deadline, then you don't see it. You see the homework assignments description here, but if you click it, then you do not see the Dropbox. Then alternative way is that you open up email message, and then to me, and then attachment. This is the way that I discourage you to do, and I want you to understand that there will be some disadvantages, or do not expect full credits from there. Okay, back to. Okay, then we go for real lecture. Okay. Why data mining? Data reflects the real world, and data has been collected and stored. Therefore, the size of data is always growing, one direction. There's no way that shrinking data size. Since data reflects the real world, if you look at data, luckily if you find some from your data sets, then you can understand the real world more clearly. If you have data, historical data, for example, data in 20 years ago, data in 10 months ago, and 9 months ago, or data in 100 days ago, or 99 days ago. If you have a series of historical data, then you can see what has been going on in that real world by looking at the data which reflects that real world. So now it is the time that we need to look at the data. The critical applications that take advantages from data mining is the advertisement. You all know that, right? For example, Google server. Of course, Google server provides you Gmails. Okay? So Gmails, initially, there is no advertisement. Free mail services. As data collected, stored, the size of data is growing. At a certain point, the Google understands that, hey, this guy is interested in digital cameras rather than hiking boots. How do they know? By looking at the content of your email correspondence. So Google reads all of your emails and then says, oh, this guy is interested in, this guy wants to study, for example, cybersecurity. Then there is a advertisement. So Mercy College cybersecurity program wants, it needs to recruit new students. Then ask Google. Then Google looking at your emails and, hey, this guy wants to cybersecurity. Yeah, let him know that Mercy College has a cybersecurity.
Not
There's
on
a
email, right?
Huh?
The search, whatever you search, they look at Google has.
Oh yeah.
Google, everything.
If you get in the Google search engine, then search engine nowadays knows who you are. Previously, they don't count much. So arbitrarily, oh, somebody coming. in and find out some website from our search engine. But now Google knows that who you are because you also open up Gmails. Then Google knows that, oh, this guy wants to search, for example, nuclear bomb. David looking at the nuclear bomb all the time. Okay.
Sorry.
William looking at the keywords, how to make bomb.
Okay,
Multiple times. Then Google says, hey, FBI, that guy is in the blacklist. That is possible, right?
and America can do that.
That is data mining. That's the data mining.
Searching. Freedom of speech. So I mean, recently
Somebody wants to see ISIS so many times. ISIS, no space in between.
Recently, I was trying to find the hours of Stop and Shop in Pomona, over in Rockland, and I said to Cortana on my PC, when does Stop and Shop in Pomona close? And it told me for Pomona, California. And then I asked Google now, and because my phone knows contextually where I am, I said, when does Stop and Shop in Pomona close? It told me Pomona, New York. So it can't be useful and scary.
Oh yeah. Techniques developed for data mining till a decade ago was in data from one domain, one application domain. Now data mining is considering seemingly, two data sets seemingly unrelated two data sets applied to the data mining process, and eventually they may find some linkages. So previously unknown linkages can be found, which is useful, right? Your GPA or academic performance can be affected by your zip code. I'm sorry. May not be true, right? Who knows, right? We do not know yet, right? Not zip code. But, for example, altitude. Maybe so, right?
Well,
I'm just thinking.
If your zip
So
code
your
is in-
your GPA is somehow correlated with altitude. If you live 1,000 feet high, and if you stand on the soil, then your GPA is high. Even if you live 1,000 feet above, but you sit on concrete, then maybe negative correlations. Something like that, okay?
If you're like in an area where people are more educated, though, that could have a correlation too.
Oh yeah, thing is this. Something that you assume, something everybody expects, and therefore data mining also provides you something that you expect, then still that data mining is good, but that is good only in the context of verification. Okay, I verified. That is true. My assumption, my hypothesis is verified. Only that much, right? But on the other hand, you never expected it before. Nobody knows. But all of a sudden, data miner gives you some fact. Once you know that fact, now you realized, oh yeah, there is a correlation. Right? That is the thing that that I want you to find. So who knows, from this course, this is a very critical time point in time, so that you will be a billionaire from this time. You find something surprisingly valuable. Surprisingly valuable. Nobody expect but me. I expect you to find some. Okay? All right. Data collection and data availability. Automated data collection tools. Oh, this is very common nowadays. Automated data collection. Can anyone give me examples of automatic data collection?
When you purchase something,
Long time ago, then you have to anybody, when I was a student, there is a student job. Usually, student jobs available on campus or outside is data entry position. There's a position called data entry. What do? Is they key in the data. There's a printed data, so the company asks you to put it in the system. It's not automatic data collection, right? There's a manual. But now, automatic data collection tools are available. It's not just buying. Buying is possible. Automatic. For example, from web page, you can find automatically by making small program. What else?
Is web cookie a data collection tool?
Cookie is just a file, right?
I was going to say the tracking cookies. Like if you
tracking cookies.
The other day I bought a coffee pot, and I'm getting this ad on Facebook for coffee pots for Kohl's.
Okay.
So,
Uh,
not that I'm browsing the internet, I just have
Okay.
it open.
but you can find you can
No, I'm really not.
you can make a small web data collection software, if you like. I made one. It's running here. Did I give you demo? I think I made it a few semesters ago, right? Oh, you took 505?
No, I didn't take 505 actually, but I would love to see a demo.
Okay, anyway. Automated data collection tool. One typical automated data collection tools is from sensor. Wireless sensor. Not necessarily wireless sensor. Sensor device can collect the data 24/7, consistently, continually. Give me an example of sensor device. One sensor device is a surveillance camera, right? Camera continually take pictures and send to the server.
Infrared?
There's a temperature sensors. There's all kinds of sensors available. Medicals. Oh yeah.
Infrared sensors. Things like
Which one? Yeah, infrared sensors. All kinds of infrared sensors available. X-ray sensor, or sonar sensor, or light. Yeah, infrared is a light. Different frequencies, different sensor devices available. So it can capture the data and then transmit the data continually. How come it is possible? How come sensor sensing data continually? Because it is possible because there is a small device also available, which is called microcontroller, like Arduino, right? Arduino is one of such. Idea of microcontroller, the programming idea of a microcontroller is this. The idea of programming effectively used for collecting sensor data is opposite from typical programming concept. Typical programming concept, when they learn loop, when they learn while loop, for loop, when they learn iterations, then there is a one rule, always warning, cautious. What is it? Your program should stop. Your program should terminate. Unless otherwise, your program runs continually. Finally, your PC will stop. So that is all. That is the rule number one, right? All the time. So whenever you do iteration, you have to make sure that this iteration stops at some points. That is a typical programming rule number one. The concept for a microcontroller, therefore, automated data collection possible is to do endless loop. You need to make some operation never stop. Continuously run, which means surveillance camera continually take photo. There's no termination.
So wild truth, basically.
While true, but that is a typical programming.
Yeah.
In microcontroller, only two blocks: loop and setup. Setup is the initial setup. Once it is set, then do this loop continually. I don't know, but maybe hint from that microcontroller programming. MIT Media Lab developed a language, I mentioned about processing language. So your web page is not just static page. It's not flash animation. It is a programs. It is a coding. It's text file. But it interacts with you. You can play. If you put your mouse some of your web page, then it responds back to you. Not through any animation tools, but typical text-based web pages can do, right? That is also according to that concept. Concept is two modules in your program: setup and then loop. by having loop, your data sensing continues. Major sources of abundant data. Business has abundant data. For example, web, e-commerce, transactions, stocks, banking transactions never ends, right? Science, remote sensing. For example, the hospital patient sensor should not end, right? Okay, let's move a little fast. Otherwise, or I think we need to take a break. That's better, right? Let's take 15-minute break. So come back by 8 o'clock. I think you understand why data mining and data mining is important. Evolution of sciences. Before 1600, empirical science. Whatever you do, science is nothing but hands-on. There's no theory at all, because that is dark ages, right? Till this point. Let's see. Hold on. Let me bring up pen. Oh, here we go. 1600. Okay, 17th centuries. And then recent years, like 60 or 70 years ago, we have a theoretic science. Okay. So physicists, mathematicians, and all engineers are working on in theoretic components, and after that we have computational science. So last 50 years, most disciplines have grown a third and computational branch. Empirical, theoretical, computational, ecology, and physics and linguistics. Computational science traditionally meant simulation. Okay. And after that, data science. I wanted to look at here the keyword empirical, theoretical, computational, and data. You see some flow from empirical to data. Before 1990, anything that you need to do using computers, then computer programs guide your life. So if you want to use computer, then you have to understand, for example, what it expects. Data science, the program itself follows data, not just use data, but follows data characteristics. So depending upon the data sets, your program behaves differently. Previously, your program defines the behavior, so data is generated based on the guideline of your program. So program generates the data that you have, then you can see the program. Now, data is generated every corner of the world. And data reflects the real world. If you run the program, then your program needs to be adaptive to data. Okay, data science. Let's read the bullets of the data science. Flood of data from new scientific instruments and simulation, ability to economically store and manage petabytes of data online. So online. Internet and the computing grid. There is old terminologies, but from these terminologies, right now we have cloud computing possible. Okay? So it's nothing but clouding. Makes all of these archives universally accessible. Scientific info management, acquisition, organization, query, visualization task scale almost linearly with the data volumes. What does this mean? Almost linearly with the data volumes. If it is not, what does that mean? If it is not linearly with the data volumes, then your management, acquisition, whatever described here, works to certain limit. Your visualization works at most 1 million data points. Beyond that 1 million data points, visualization is no longer available. That type of things is it's not linearly with the data volumes. In other words, it is like exponentially with the data volumes.
Is this where we get into like big O notation and that kind of stuff? Or?
Big O, yeah, it is related with big O notation, right? Because our computing power is now stable and linear, therefore your program can handle linearly with the data volumes.
So it scales
Yeah,
up.
that is true, yeah. It is scalability. Data mining is a major new challenge as technology evolves. Okay, as technology evolves, computer can handle big data. Is that true? Not quite, but very close. Jim Gray, he passed away about 20 years ago. He was in Microsoft Research. Before he joined the Microsoft Research, he was in Harvard. Maybe. But I'm sure he was in Microsoft. And he likes yachting. So at one Sunday, he departed from Seattle port and disappeared. His body was not found. But anyway,
Who was that? What was his name?
Jim Gray. He was the winner of ACM Turing Award. You know Turing? Alan? Do you know? Alan Turing. Right. Cryptography is. Right. Yeah. ACM has an award for that given to computer scientists. Jim Gray was the awardee, I think 20 years ago. When I was a student, he was awarded. He looks weak. One of his best friends is Stormbreaker. He was in Berkeley. He's tall and strong. Now he is in Harvard. His friend takes his position. Anyway. So, in 2002, it was not 20 years ago.
He
Or
died
around,
in
yeah.
2007, I think.
Died in 2007?
From what I read, he disappeared in 2007.
Oh, it's in the
It's on
web page?
yeah.
Oh, okay. I thought 20 years ago, but not long ago. Only 9 years ago then. Okay. So what it says is that he wrote an article called The Worldwide Telescope, Archetype for Online Science. See, here's online science. Data science, that is popular keyword right now, right? Online science would be the next generation? I'm not sure. Have you heard of that terminology, online science? Maybe, right? Online science. Makes sense. We are ready for online science. But anyway, evolution of database technologies. 1960s, data collection, data creation, IMS, and network DBMS became available. In 1970s, relational data model, relational DBMS implementation. So first DBMS implementation was done by C.J. Dates when he was in IBM Almaden. Not IBM Watson, IBM Almaden in West Coast. West Coast IBM has a computer science research center. 1980s, RDBMS, advanced data models, so that extended relational, look at this, extended relational, and OO, object-oriented, and deductive. I worked a lot in deductive databases. What it does is that database itself deduces some. Okay, it's like artificial intelligence. Application-oriented DBMS became popular in 1980s. For example, spatial database. Before we have a spatial, this application-based DBMS, the DBMS has only contains alphanumeric data. Now, spatial data means any data about space. Okay, 2-dimensional, 3-dimensional. Scientific data. Early days of database technologies can do only business data. But now, not now, I mean 1980s, scientific data. For example, civil engineering, when they build streets and roads and railroads, whatever, then they put that data in the database so that the database can produce some data for civil engineers to use. That was possible, engineering database. In 1990s, now we have data mining, data warehousing, multimedia data, and web databases. Web databases still very, very popular, right? Because web pages can be generated from databases. not created but generated. 2000s, streaming data management. Data is not just static. Data is not just the data that can be stored. That is streaming. Streaming data, then therefore it is not stored. There's no time that you can store. The data keep coming in. If you want to store data, then you need to have endpoint. Store data. How can you store data? Then the outcome of data store is a file. If it is a file, then that is the end of a file. But there is no end if it is a streaming data, right? If we do data mining against streaming data, oh, that is tough, right? If it is stored data, therefore you can open a file and read from first line to the end of the file and do process. Oh, that is very common. If it is streaming data, for example, data coming from medical sense devices, so that sense device keep monitoring the patient, sending data, so my computer receiving that data continually with the time points that I can do. Okay, apply data mining. Oops, new data coming in. Okay, after you. Oh, more and more. So there is no algorithm available. Yes, there is some algorithms developed, right? Very, very useful algorithms that can handle streaming data. Data mining and its application, web technologies, so XML and others. Possible. So what is data mining? Finally. So today, at least you need to understand that when your mom asks, what did you learn from data mining? Then you need to say, oh, by the way, data mining is the extraction of interesting patterns or knowledge from huge amount of data. That's it, right? So what is data mining? Extract. That is a process of extracting interesting patterns from large volume data sets. So alternative terminology for data mining is knowledge discovery. Okay. So since 1990s till now, everybody said, oh, this is data mining, this is data mining, or this is big data, this is data science, this is data analytics. Watch out. Is everything data mining? For example, simple search, is it data mining? Like gold mining or coal mining. Coal mining, then whatever you extracted, then that is a coal mining, right? Is the same in data mining? No. Like a search, if you search, then is it data mining? I would not say no, but it's not a real issue that we want to discuss in this class, right?
I mean, the data
We're not talking here how to search web pages.
The data used from your search, though, can be used for data modeling, though. So, like, if you enter a query and then you enter a bunch of queries, they can do things based on those queries.
So that is a loosely coupled data mining, not real core data mining. Deductive systems. Anything deduced from a system, therefore can be called data mining? Again, somehow yes. But if we will say it is the reason that we are discussing data mining here in this class, no. Right? You can find it from some other class. Oh, by the way, we do not have. KDD process. What is KDD? Stands for knowledge discovery and data mining. Right? Process. This is a view from typical database system and data warehousing communities. Data mining plays an essential role in the knowledge discovery process. So, starting from here, left to lower end, we have a database, which is nothing but data sets. So we clean the data. Why do we need to clean? Because there is a lot of garbages. I do not want to find something from garbage, or whatever the pattern that I eventually expect to have to be influenced by garbages. I want to capture patterns which reflect purely the application domain, which is my interest. Therefore, I do not want something badly influenced by garbage. Data cleaning. That's the first phase. If we collect data at time point 1, at time point 2, and time point 3, therefore we have historically available data and all dimensional data together, along with the timeline. It is called data warehousing, and it is drawn like a cube. Because this is very big, data warehouse is nothing but big data sets. But for some reason, for example, computing power was, for some reason, I do not want to work on entire data warehouse, but I want to work on some selected, and then apply data mining. When I have patterns, using multiple patterns, I finally have a rule. For example, student lives in 10,000 feet high above and sitting on the soil, gain GPA 3.5 or above. That fact is true 75%. Then that is knowledge that we can use. That may not be true, but example of web mining. I want you to take a look. Data mining and business intelligence. In business, we have data source, and then data integration. Therefore, we have data warehouses, and explore on that data warehouse. For example, query, as you said, or some summary. Summary is very, very important when you have a big data, right? Particularly if it is a business data, then your CEO wants to see, so what is that? What is about that data? if you explain, oh, in part A, in another part B, in another part C, if you say all broad explanation about your data, then your CEO may not be happy, right? So somehow summarization is also very, very important exploration. So summary, querying, reporting, through that you discover some. There's data mining, and then present that data mining outcome. Finally, your CEO can make a critical decision. So decision making on top, right? Which is good. So some differences between mining and data exploration. But in this class, we do not really differentiate those two. We do not need to. KDD process, typical view for ML. What is ML? ML is another popular word. Machine learning, right? Typical view from machine learning and statistics. So KDD can consider a process in this way: input data, pre-processing, data mining, post-processing. And though in such processing, then you can see pre-processing, we have data integration, normalization, feature selection, and dimension reduction. Feature selection, for example, if we want to mine image data, or if we want to explore the image data, image data contains how many features? Image data has color feature. Image data has pixel features. Resolution features. Image data has
EXIF data attached to it.
yeah,
Metadata.
EXI, yeah, whatever that is a format. It has some objects in it, right? Image data has, for example, if it is this classroom, then there's a number of students, and then desk and computer and whatever, right? Somebody has a MacBook, somebody has Windows, and somebody has glasses or no glasses, somebody has a hat. So, those are all the information about. There's all features that you can extract from images, photos. So many features, right? We call that multi-dimensional data. If you have so many features, although you can extract from the same image, almost impossible to produce some data mining. Why? Because too many features. So somehow we need to do reduction, which is called dimension reduction. When you describe a dog, which is completely different from tiger, then what is the feature? Then you can describe a dog. Therefore, computer can identify, hey, this is dog, and that's a tiger.
Dogs bark. Tigers don't bark.
I don't know. I've never heard any sound from tiger. Tiger has some
Tigers growl.
growl, yeah.
Growl. Yeah.
It's not. We don't call it bark.
No, I was saying
right?
dogs bark.
Yeah, dogs bark. Okay.
Tigers
that's
don't. They usually eat you.
Yeah, there's some. But when we want to discriminate one from another, if we use so many features, then There's no distinction in between, right? But if you have one or two very critical features that can make the difference, then that is a good features. Pattern discovery, association and correlation. That's a data mining algorithm. Pattern discovery, correlation, classification, clustering, outlier analysis. So those are all the topics that you might consider for your project. So think about one of these. Oh, I like feature selection from, if you are familiar with EXIF files, then yeah. Post-processing, pattern evaluation. Once you generate pattern is the outcome of data mining, then you need to evaluate the quality of data mining. Since it produced patterns, then you need to say, hey, this pattern is good, this pattern is useful, this pattern is interesting. Somehow evaluation process is needed. To evaluate, what you need some measurement, so-called the matrix. What is the rule? What is the formula? Therefore, you can say this one is better than the other, or vice versa. Pattern selection. Let's assume that they are all good pattern. Now, which pattern do you want to apply for your next cycle of data processing? Are you going to use all the good patterns that you obtained? Oh, there were so many patterns. For example, you discover the pattern. Therefore, when you look at the network packets coming in, then looking at the network packets, you can say, oh, this is intrusion. Oh, this packet, oh, that is my good neighbor. So on and so forth. So you finally have some patterns. Such, therefore that is a good pattern. Such, therefore that is a bad pattern. And you have multiple patterns. If you apply some rules, some data mining algorithms to varieties of network packets, then you end up having 1,000 patterns, all useful. Let's assume that you have 1,000 patterns. And now, in real time, that you want to watch incoming network patterns. You have 1,000 patterns available. Oh, let me apply this. Oh, this packet passed away. New packet comes in. Oh, which pattern that I want to use? So pattern selection is very, very important. By looking at, for example, one features of packets, then you need to quick select pattern that you have from your pattern database and apply. Right? So all such things is a process. Okay? Pattern integration, pattern visualization. Visualization is somehow not really pure data mining concept, but visualization cannot be ignored. Why? Why do we do this data mining? This is for your boss, your decision maker. Whatever that you have will be presented to the president of the United States. So president can see this. President says, oh, I have a headache. I do not understand. Can you show me another way? Visualization, right? Very nice visualization. Then the president can see, oh, yeah, I understand. Next. Okay? Next class. Come back next class. Have a good night.
Thank you.
You.